Hello everyone. This is Introduction to Data Structures course. This is Jean-Paul Jung. Today we are studying Chapter 6, List Plus. What is a class template? A class template allows the compiler to generate multiple versions of class type by using type parameters. Actually, actual parameter determined during runtime using template class. Okay. The formal parameter appears in the class template definition, and the actual parameter appears in the client code. Both are enclosed in pointed brackets like this. Okay. So this is class template. Okay. Stack type. So actual element integer. So actual parameter. So we have a stack array, this one. Okay. So this array items, right? Array we item type case we can decide during runtime. Similarly, float type also we can define, also string type also define. So this is a class template definition, include the item type. This is okay, array, okay, items, okay, type. Also define the maximum number of items. Okay, so template class item type, so we can make actual parameter item type using this kind of formal parameter list. So class stack type, we can define public function, private, and the private member variable, the item type, and items, right? So this type determined by template. So also we have sample class member function. So construction case also we can construct, okay, using template, okay, class template, item type. This is a formal parameter list. Similarly, the push function case also the pushed new item type also decided by this class template. Okay. The using class template, the actual parameter to the template is a data type, like integer, floating type, and string type. Any type can be used, either built-in type or you define the types. Templates are instantiated at running time, actual execution time of a program. Can you see how this might cause a problem? Okay, think of it. When creating class template, we can use .h and .cpp in the same file, or we can have the h include, okay, .cpp file. What is a circular linked list? We are see circular linked list and also doubly circular linked list, also circular double linked list. Okay, so circular linked list case, you can see previously we have the list data point at the first linked list node, right? And then circular linked list case, last node next point to the first node. Okay, and then this makes a circular. So list data can point D, doesn't matter because this is circular, right? So we can point all list node. Okay. Also B case, the first node, if we deleted this one, just list data value is null because this is empty string, empty list. What is a doubly linked list? Okay, so doubly linked list case, it has two pointer. This is next, this is previous. Okay, so next means a successor, previous means okay, predecessor. Okay, which means this one is a kind of parent, this is a child. Okay, so we can link to each other. And then if we make a new node case, we create new node using new, and then new node, the previous point to this Joshua node, and this next node, successor node is Miriam. Okay, and then Joshua's this next point to this Leah, and Miriam the previous point to this Leah, and then we can make a doubly linked list. If we delete a node from a doubly linked list case, we delete, right? So before, okay, delete and this node, this is a location point deleted node, right? So in that case, this previous node and the next successor node should be linked to each other, right? So this Miriam's previous point to this David node, David next point to Miriam node, and then we can maintain doubly linked list. The water header and trailer nodes, we have header node and trailer node. This one is place holding node. Okay, so it is simplify list processing in insert delete. Okay, something like that. So header node is a node that, okay, this is at the beginning of a list that contains a key value smaller than any possible key. This is a small minimum value, and this is a maximum value. Okay, so trailer node is a node at the end of a list that contains a key larger than any possible key. This is or G means the maximum value. Both header and trailer are placing hold nodes. We mentioned to simplify list operations. Recall definition of a stack, logical entity abstract data type level. A stack is an ordered group of homogeneous elements are all the same type, in which the removal and addition of stack items can take place only at the top of the stack. This stack is called the LIFO stands for last in, first out. Lastly inserted one, first, okay, pushed, popped, okay, this is a stack. So stack type in, okay, using template. So private data top pointer point to stack, okay, this items, okay, linked list. So what happens when a function is called that uses pass by value called call by value, okay? So for a class object like our dynamic linked stack like this, okay? This one is, okay, our stack, top pointer point to the stack items. So this, okay, stack, this list not protected, but this top pointer protected using this is private member variables, right? But this is not protected. So by call by value or call pass by value makes a shadow copy, which means okay, we can have this definition using class template. Okay, my stack defined here, my function called, and then my stack is parameter passed. So internal function we can using this one. Okay, so some stack in my function, this copied, right? So my stack case, we have this one, and then this one is copied, but this top PTR, this one is created, but stack items linked list not copied, because this is a shadow copy. They are share this one. Okay, so what's the difference? We have two concepts. First one is a shadow copy, the second one is a deep copy. Okay, deep copy is this is preferable. We can see a shadow copy shares the, okay, pointer. Okay, this one is a pointer to data with the original, okay, class object. Okay, and a deep copy stores its own this okay, own copy of the pointed, okay? So pointed one means, this pointed means linked list for stack items, okay? To data at different locations than the data in the original class object, okay? So actual copy is stored. So make a deep copy case. This is my stack, and then we can function call my function. Parameter of my stack is called, and then the scope of my function, within this function, some stack is created, okay? So this private top PTR pointer created. Also the list also nodes are created. This one different because the address of this node is different, right? 7,000, this is 5,000. This one is address is 6,000, this is 2,000, right? This is called the deep copy. Suppose my function uses a pop, okay? So my function, okay? This one is my function, and then some stack. This is a parameter, right? Using pass by value. That is a call by value. And then here the item type we can pop, okay? So some stack we can pop something like that, okay? So if we using the shadow copy case, what happens? Okay, so like this. So we can pop first the top one, right? So this one. So my function within function body we actually pop, but outside my function after call of my function, my stack original one case lost the first node, okay, but still a point. This is a problem, okay. This is a kind of pointing deleted node dangling point, okay. So notice that the shadow copy and the actual parameter my stack have changed like this, okay. So as a result, this default method used for pass by value, call by value, is not the best way when a data member points to dynamic data like linked list. Instead, you should write what is called a copy constructor, which makes a decopy of the dynamic data in a different memory location. This is the decopy. So more about the copy constructors, okay? When there is a copy constructor provided for a class, the copy constructor is used to make copies for pass by value, call by value. You do not call the copy constructor. Like other constructors, it has no return type. Because the copy constructor properly defines pass by value for your class, it must use pass by reference, okay, rather than pass by value. That is called by reference in its definition. Copy constructor, let's see. Copy constructor is a special member function of a class that is implicitly called in these three situations: passing object parameters by a value, initializing an object variable in a declaration, returning an object as a return value of a function. So this is the code, okay, for copy constructor. So in the middle, we can, this is default constructor. Second one is the copy constructor. So copy constructor case, we have this one, constant stack type, another stack. So using reference, okay, call by reference, okay, and constants. And the copy constructor implicitly called for call by value, okay, but here we can using call by reference. This is the structure, okay. So classes with the data member point need, okay. So class default constructor, class copy constructor, and class destructor. Okay. So here is the implementation of copy constructor. So template, okay, class item, and this is scope resolution, okay, and stack type constant, another stack, right? So core by reference, okay. So and then you can see ptr1, ptr2, okay, and then another stack. This null case is just top pointer null because this is null, okay, stack. Otherwise we can copy, also allocate the memory for first node, okay. So this one is top node, new, and this, okay, info is a copy into top info, and then another stacks, okay, this one, another stack top next is a ptr1, okay, point, and ptr2 is a top pointer. So eventually top pointer and pointer 2 the same, okay, objects are, okay, pointing, and the ptr1 is point the top ptr next node, okay. And then we can performing this while loop, decopy other nodes, okay. So we create new node and then ptr next, okay, ptr next is top point, okay, so next, actually ptr1, okay, this one actually copy will be copied, right? So and the ptr2 next, okay, and then ptr next, and this assigned to ptr2, and then ptr1's, okay, this one actually another stack, right, value copied, right, and then ptr1 is moved to next one, okay. So this one is ptr next, actual ptr2 is current copied node value, right? So using this kind of iteration, we can copy from another stack using ptr1, and then new stack copied node, right? Like a decopy case, this one we can copy from ptr1 information, okay? And then after that, ptr2 next is null, okay? So actually the end of the stack. And what about the assignment operator? The default method used for assignment of class object makes a shadow copy. If your class has a data member pointer to dynamic data, you should write a member function to overload the assignment operator to make a decopy like the decopy constructor for dynamic data. So we have, you can see operator overloading here. This is called assignment operate the overloading. So operate assignment. This one is overloads assignment operator assign, and then stack type item type class template. So C++ operator overloading, guys, okay. First, all operators except this scope resolution operator or dot. This is object of structure access member variables or member function, and the size of this is okay, condition, and true case +1, first case second one we can choose, right, may be overloaded. Secondly, at least one operand, okay, argument of operator must be a class instance. Thirdly, you cannot change precedence operator symbols or number of operands, okay. This is the order of application of operators. Firstly, overloading plus and minus requires a prefix from use by default, okay, unless special mechanisms used. Fifthly, to overload these operators, assign, parentheses, and square bracket, the member functions, not friend function, we can study friend function later on, must be used. Sixthly, an operator can be given multiple meanings if the data types of operands are different. Okay. So using overloaded binary operator, okay, plus case, two operands arguments are required. Okay. Firstly, when a member function was defined, like your stack plus your stack, my stack plus your stack, and then my stack dot operator plus your stack. And when a friend function was defined, okay, so my stack plus your stack, and then operator plus case my stack your stack. So we have a different syntax like this, okay, using friend function, because they are friend, okay, to stack variables. Okay. Sorted list stored in an array of nodes. Okay, so this one is sorted list. Okay, so nodes. Okay, this array we have this kind of thing. So information and the next one. Okay. Okay, so and the list case 0 means actually list item nodes number, and an array with linked list of values and free space. Okay, and then this is the list, the start, this one. Okay, so this list the start of this one, and then the next one is actually this one, 4, and then 7 is the next one, 2 is next one here, 6 next one, this minus 1 is end of the list. Okay, so the pre space. Okay, so this indicate, okay, the pre space. Actually, if we insert new node, this one is used, right? However, the list indicates 0 indicates the first node in the list. Okay, 4 is this one, and then 7 is this one, 2 is this one, 6 1 is this, and the null. Okay, minus 1 previously, right? So end of list. An array with 3 lists, including free list. Okay, so list 1, one case this one, right? 0, 4, and 8, 9 null. So we have a list 1. Another list is pointed list 2. 1 is this, 5 is this, 6 is this null. Okay, so we using the third nodes array, we can maintain 2 lists called the list 1 and list 2. Okay, next, polymorphism with virtual functions. Okay, so virtual function case, in the class we can have the same function name, but we can make some placeholder in the some base class. But child inherited class case, we can define specifically according to that class. Okay, so the virtual class is actual implemented by the child class. So the former parameter that the member function. So this is a member function. The former parameter is used as follows. First, if a member function is not a virtual function case, the type of the former parameter determines which function to call. This is called static binding is used. On the other hand, secondly, if a member function is a virtual function case, the type of the actual parameter determines which function to call actual parameter. Previous one is a former parameter. So this actual parameter, this is argument, right? Determines actual function call. So it is called the dynamic binding. Okay. Okay. Lastly, discussion on circular doubly linked list. We saw circular linked list. Okay. So we have 3 discussion issues. The first, how to make a circular doubly linked list from a doubly linked list. Secondly, what are the advantages of a circular doubly linked list? Lastly, how to add or delete a node in a circular doubly linked list. Okay. Okay, if you have a question, please let me know. Thank you for your attention. Bye.